All right, guys, second lesson for today. Let's talk about applying linear relationships. Okay. Applying linear relationships. This is part 2 of the review that we just did. Obviously, the first one was 20 minutes or so. This one's not going to take as long. I just want to cover some main points. Okay. We might get through all of this. We might not. Honestly, I don't know. I just want to make sure I cover the main points. Okay. Make sure you put a star next to where it says parallel perpendicular lines. You are going to see that. Okay. Please focus for me. Thank you. Keep your bubble gum in your mouth. I'd rather not see your bubbles. All right. All right. Parallel lines, same slope, perpendicular lines have opposite reciprocal. Flip it, change the sign. Once you find the slope, if you flip it and you change the sign, it's perpendicular, okay? If you multiply two slopes together that are perpendicular, they should always equal -1, okay? So perpendicular lines, when you multiply them, they will always equal -1. They will, don't put x equals. If you multiply two slopes together, they will equal -1. If they don't equal -1, they're not perpendicular. The only difference to that is 0 and undefined. They make a 90-degree angle. Okay, they are perpendicular, but if you multiply 0 times anything, what are you going to get? But so undefined just makes everything funky. Okay, unless you're Chuck Norris. No, I think even Chuck Norris gets 0 on that one. Okay, all right, here we go. We're on an equation of a line that is parallel to the x-axis. Parallel to the x-axis. So if the x-axis does this, what kind of line is parallel to that? Parallel. Parallel means the same, right? Would you agree? Okay. So what does this? Is it x equals or is it y equals? Okay, so do me a favor, write that down somewhere. This is always going to be x equals a number. That's x equals a number. Oh, no. Sorry. My fault. That's backwards. That is my fault. That is y equals a number. Y equals. Sorry, that's on me. X equals is undefined. Okay, it's always opposite of the. It's opposite. Remember I told you guys that it's opposite. The x-axis is this, but the x equals line is this. Okay, so x equals is going to be up and down. Okay, the way I remember this is x equals x bad. I don't want this undefined. No bueno. Okay, for you Italians. Okay, all right, everybody good? What? You're Italian? Good. Then you're welcome. Okay. All right, here we go. So if it's parallel, listen, if it's parallel to the x-axis, that means I'm going to choose this one. So I'm looking for y equals. So I'm going to go y equals. What's my y number up there? Done. Y equals 6. Seriously. That's how hard that problem is. It's parallel to the x-axis, so it's still the x-axis. If you were to take your Desmos and type in y, or you go to your calculator, type in y equals 4. If you go to the y equals and just put a 4 there and hit graph, it'll be sideways. Okay. Write an equation of a line that is perpendicular to the x-axis. So if this is the x-axis, what's perpendicular to that? Boom. What is it? X equals, right? So what's my x number? 1. Done. Okay. Perpendicular. That means it's going to flip. All right. These, I'm going to do one of these because I just don't have time to do both of them, okay? An equation of standard, write an equation in standard form of the point that passes through the point 0, 9 and is parallel to this. Now, first of all, they gave it to me. That's a y-intercept. Would you agree? That's a y-intercept. That when I'm reading this problem, I see 0, 9, and I immediately think they just gave me a y-intercept, okay? So y-intercept, and it says parallel to this. What does parallel mean? Same slope. So I'm going to take that slope. Y equals -x. What's my point? What's +9? There it is. It is parallel and it goes through that point. Now, if they didn't give it to me that easily, like if they actually gave me a point, I would have to do point slope form, plug in numbers, do it that way. Okay. But they want it in standard form. What does standard form mean? What do I have to move? I need to move the x to the left side. Okay, so -x becomes a what, guys? X plus y equals 9. There it is, the standard form. I basically took the -x, put it over here, made it a positive. That's all I did. If it's not a fraction, it's easy. You just move it over. Everybody good? I'm not going to do this one. I just don't have time. Okay. Everybody understand parallel perpendicular lines? Parallel lines, what's special about them? They don't what? They don't ever touch. They do not cross. Okay. Parallel lines do not cross. Okay. Or look like they're going to cross. Okay. Because I actually saw one where somebody had this and then like this, but then it got to the edge of the graph, but it never actually fully touched. Is that one eventually going to touch? Yes. Those aren't parallel. Okay. You know what's parallel. Okay. All right. Moving on. Transformations. Transformations. Negative fx. Okay, so negative f. So we have a lot of information. Transformations. All right, I want to make sure I have all the wording. Negative is a reflection. And it changes the direction of your slope. Okay, it changes the direction of the slope. Okay, in other words, like negative y. Okay. Now, I'm not worried about the dilations and all that other stuff, okay? Okay. 3fx, we don't need to worry about that. Means it's steeper. Okay. I want to go down to this right here. fx plus d and f plus c, these are called transformations. This is what we actually covered this in class. Transformations. And these change the y-intercept. These change the y-intercept. Plus 3 means it goes up 3 units. What do you think negative 3 is? Down 3 units. Up 3 units, down 3 units. Transformations. Okay? I'm not going to spend a whole lot of time on that because you might see one problem. Okay, I want to get through the rest of it. You are going to see this next part quite a bit. Okay, linear inequalities. All right, here we go. Everybody good? All right, let's do these. What do you notice about the lines? They're solid or they're what? Solid or dashed. Here we go. This one, is it solid or dashed? Is it shaded above or below? So it's going to be greater than or equal to. It's shaded above the line and it's solid. Remember? Okay. This one is solid and shaded below. What would that one be? Yes.
I was going to ask, so the line below is right or equal to, that's if it's a solid line.
Here's the way I always learned it. If it is a line, it has a line. If it's a line, it has a line in the equation. Okay, everybody with me? This one. Is it shaded above or below? Solid or dashed? So how do I write it? Less than or equal to. Good. That one's less than or equal to. Please write that down. You will see that. Okay. It's still slope-intercept form. Do you guys remember how to graph y equals mx plus b? Yes? No? Hit your point, and then from there, like if your slope is 3/4, I go up 3 over 4. Solid line, dashed line. Okay. All right, here we go. Solid or dashed? Dashed. Shaded above, right? So what would that be? Greater than. That one's dashed. Reminds me of who? What's her name? LaDasha. LaDasha. Okay. True story. True story. Okay. What? That was a... You just call me ancient. Okay, go on. All right, here we go. So this one would be what? Less than. Good. All right, so we're going to graph this one. Okay, we're going to graph this. All right, to graph it, what do I need to put it in? Y equals mx plus b. Move the what? Move the x divided by y. So positive 3x becomes a what? Negative 3x. So now I've got negative 5y less than or equal to negative 3x plus 10. Yes? All I did was I took the 3x to the other side, and here's what I like, because now we're going to actually practice a little graphing. Okay, we're actually putting stuff into the correct form. Now, what do I divide by? Negative 5, negative 5, negative 5. What happens? Y is greater than or equal to. Why? Because I divided by a negative. What's the rule, guys? When you multiply or you when you multiply or divide by a negative, not into a negative, but if you divide by a negative, okay? Like I just divided by -5, okay? Because I divided by a negative, I flip the arrow. Okay, I have to flip the arrow. All right. 2 negatives make a what? Positive 3/5. 10 divided by -5. -2. Cool. Let's graph this. So -2 is my y-intercept. And my slope is 3/5. Agreed? So I'm going to go up 3 and over how many? 1, 2, 3. 1, 2, 3, 4, 5. And just for the sake of having another point, I'm going to go down 3, left 5. Why does that work? What is down, down? Or what's down and left? What is down? Positive or negative?
Negative.
What is left?
Negative.
Two negatives make a what? It's still in my positive slope, so I'm still okay. All right, solid line or dash line, guys? Solid. Now, here's where it's a little trickier. Greater than or equal to. So which way do I shade? Y above. Because it's greater than. So everything in here should be true. Yes? What's the point we always check if it's not on the line? 0, 0. Okay, let's check it. So you don't have to do this, but I'm just going to mentally do this. I'm going to put 0 for y. What's 3/5 times 0? 0. What's 0 minus 2? Nope. What's 0 minus 2? -2. Is 0 greater than -2? Yes, it is. It's in the shaded area. I'm feeling pretty good. I like my answer. If it's in the shaded area, it's true. I'm good. Everybody good? Right, and inequality for this one. This is actually, I think, a little bit easier. Okay? What's my y-intercept? Here's a point. Let's find another point. How about right there? Will that work? Y. Always start with y. Is it shaded above or is it shaded below? I'm not saying left or right. I'm saying above or below. This one's shaded below and it's dashed. So how would I write that? Less than. Good. What's my slope? Down 1, 2, 3, 4, and over how many? 1, 2. What's -4 over 2? What? What is that? Say it. -2 what? X, because slope is always in front of the x. And what's my y-intercept? How many up did I go? Positive 3. There's my equation. I'm sorry, not my equation. Equation is an equal sign. This is my inequality. You guys did know that, right? Equations have equal signs. That's why they're called equations. All right. We good? We're almost there. All right. Do you guys see this data right here? Okay. I'm trying to decide if I want to show you how to do this because I'm not going to show it to you on your calculator because I think it's a whole lot easier in Desmos. Okay. So here's what I'm going to do. I'm going to put it over to the side. 0, 6, 9, 8.6, 18 and 10, 27 and 13.6, 34 and 15, 43 and 17.2, and 49 and 19.8. Everybody with me on this? Because I want to show you this really, really quick. Okay, this is kind of important because you will see this. In Desmos, it's actually very, very easy. We're going to look for the correlation coefficient. So we're going to look for the R. We're going to talk about that. And the equation. Okay, we're going to look for the equation, line of best fit. Okay, I can't really see it on the screen, but that's all right. We're going to make it work. So I already have Desmos open. So here's what I'm going to do. I'm going to show you this really, really quick, okay? Now, there's a couple things I'm going to want you to write down on this, okay? To add a table, okay? Down there at the bottom, I want you to click just add a table in Desmos. So you're going to go plus, and I'm going to hit a table. Plus table. And what's going to happen is I'm going to be able to type in all of these numbers. So for me, I like just doing the x's first, then I'm going to go back and do the y's. Make sense? So let me do this really, really quick. 0, 9, 18. So 0. Whoops. 0. Maybe. Why is it not letting me? There we go. 0, 9, 18, 27, 34, 43, and 49, right? Now let's go back up. My Y numbers. 6, 8.6, okay, 17.2, 19.8. Okay, so those are my numbers. Yes, everybody, is everybody with me so far? Please write this down somewhere, because what I'm going to do is I'm going to make an equation. I'm going to add another line. I'm going to add another expression, and this is where we did this in class. What is my normal equation? Y what? Y equals what? Mx plus b. But now it's not a perfect line. These are not perfectly set up, okay? So here's what I want to type, and please write this down. You're going to go y1. y1, and then you're going to do a little squiggly, because it's not quite a perfect amount, okay? And I want to show you how this works. And then I'm going to go mx1 plus b. Okay, I'm going to back out of this so you can kind of see the points. There's all the points that they gave me. And what your computer does is it actually gives you what's called a line of best fit. A line of best fit is basically it takes your data and it tries to draw a line through all of the data that would be the best fit for the numbers that you had. Now, the R, okay? The R number, this is important. We did do this in class. We did do it very, very short. Remember, the closer to 1 it is, the tighter the line. Okay, do you guys remember that? The closer to 1. So like if it's 0.996, that's really good. But if it was like 0.75, that would mean that the points are kind of spread out away from the line, okay? So the closer to 1 it is. So this one, my R is 0.9954. That means it's actually a very, very tight line. And if I look at my points, here's a point, there's a point, there's one that's a little bit off, here's a point, there's a point. But watch what happens. I'm gonna move this point. What is this? 18 and 10. I'm gonna move that point. Let me change the 10 to a, how about a 20? I'm gonna put it up here. Everybody with me on this? And I want to see how the R changes, because I'm gonna move that point away from the line. Does that make sense? I want you to understand what we're trying to tell you. So instead of 10, I'm gonna say 20, and now it's 0.777 because I have this one random point that's not anywhere near the rest of the line. Now it's not near as tight. Does it make sense now? The tighter the line, the closer it is. So let me put it back on 10 again. Okay. What's this letter? What's it say? M. What is that? Can I write my equation? Y equals M 0.27x plus 5.8. 3. There it is. You don't necessarily need to write that down. But what I do want you to write on your papers, you need to write this down. Y1, squiggly, mx1 plus b. That will get you to the linear regression in Desmos. On your calculator, it's just too much of a pain in the butt. I don't want to show it to you. You're going to forget it. There's a lot of other stuff to remember. Everybody good on that? Okay. Closer to 1 means it's tight. Further away from 1 means it's looser. Okay. Everybody good? All right. I think we covered a lot of information. Go ahead and take one more break, and then I've got one little thing for you. Okay? One little thing.